So in the previous lecture, we were talking about the degeneracy of rotational spectroscopy. So we'll continue with that lecture by finding out the connection between the degeneracy and the population. So if the number of degenerate state increases, the population also increases. Okay, so let's take a case where j is equal to 0. So if j is equal to 0, mj is equal to 0. That means there is no degenerate state, only mj is there. But then in case of j is equal to 1, m will be equal to minus 1, 0, 1. So and in case of j is equal to j, then mj will be equal will range from minus j to plus j. Now we will be using the Maxwell distribution equation to learn how intensity of light depends on the population. So Nj by N0 is equal to Gj by G0 e raised to minus del E by Kt. This is the Maxwell distribution. And here we take the ground state G0, the degeneracy of G0 of the ground state to be 1. So this term will become 1. You will get Nj by N0 is equal to Gj e raised to minus del by Kt. And energy, this one, the energy difference is from the jth state to the ground state, so you can write it as Ej minus E0 by Kt. And then if you remember in the first lecture of rotational spectroscopy, we derived this equation Ej is equal to Bj j plus 1 at C, and if you put 0 in case of j, you will get E0. So E0 is equal to, wherever there is j, just put 0. So 0, 0. So you will get E0 to be equal to 0. So this equation, this term will go to 0. And finally, this equation modifies into this. So Ej is nothing but 2j plus 1. And this term goes to 0. Ej we have written here. So the Maxwell distribution equation modifies to this final equation. Okay. Our goal is to find the j max. So what you have to do is you just have to differentiate this one with respect to j, and then so there's a j term here, there's a j term here. So first into the differentiation of this plus the differentiation of this into this, you just have to do that. So here 2j plus 1 becomes 2 into the rest of the terms, and then this term comes down and there's a differentiation of this one and then rest of the terms. And on solving, putting into 0 and all, finally you will get j max to be equal to Kt by 2b/c minus 1 by 2. And then k hc and all, we know the value. Just solving the known values, you will get the value to be equal to 0.5892, and the values which varies, that is t and b, you can keep like that. And finally j max is equal to 0.5892 root t by b minus 1 by 2. So that's it for today. See you in the next one.